Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So in this video, we're going to solve the problem, the path with the minimum effort. What does the question state? It states you are a hiker preparing for an upcoming hike. Okay, you're given heights, a 2D array of size rows, cross columns, where height row column represents the height of the cell. You're situated in the top left cell, so I can say that this is our source, and you have to travel to the bottom right cell. So I can say this as our destination. You can move in four directions, and you wish to find a route that requires the minimum effort. Now, a route's effort is the maximum. I repeat, a route's effort is the maximum absolute difference in heights between two consecutive cells of that route. So let us understand what does the question state. So imagine this particular grid, and we have clearly stated that this will always be the source and this will always be the destination. Something like this will be the source and something like this will always be the destination. That is clearly stated to us. Okay. Now, if I wish to reach from here to here, and we are just allowed four directions, we are just allowed four directions. We can actually go something like this, like this, like this. We can actually go something like this. There can be multiple ways in which we can reach from here to here. That is definitely short, correct? Now, if I take this path, let's write this path 1, 2, 2, and I think 2, 5. This is the path where we go here, 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 and here. Okay. Now, let's find out the difference. So, the difference is 1. The difference is 1. The difference, the difference is 0. The difference is 0, and the difference is 3. Now, out of all the differences, which is the maximum difference? Can I say the max is 3 because I have only 1, 0, and 3? So the maximum of them is 3. So this is what the route's path will take as the effort. 3 is the effort that it will take. So I can write 3 is the effort that it will take. But can I have any other path? Let's see. What if I take something like this, something like this, something like this, and something like this, which is 1, 3, 8, 2, 5. 1, 3, 8, 2, 5. Difference is 2, difference is 5, difference is 6, difference is 3. And the max effort is 6. So 6 is the effort it will take if it goes something like this, like this, like this. Can I have something better? Let's give it a try. 1, let's take 1, 3, 3, 5, 5, 3, 3, 5. Okay. So it's something like 1, 3, 5, 3, 5. Difference 2, difference 2, difference 2. Remember absolute difference 2. What's the max? 2. So 2 is the effort taken. Now what they want you to do is you can figure out the efforts in all the paths. You can figure out the efforts in all the paths, and you need to give me the minimum of them. You need to give me the minimum of them. So in this path, the effort taken is 2, and that's the minimal. So the answer to this will be 2. You can say that 0 is the minimal. No, you don't need to take individual differences. No, out of everyone, once you figure out the max, out of the max, you have to figure out the min. Out of all the max, you have to figure out the min. That is the question. So if I take the second grid, what will be the answer? If I go from here 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. If I can take all the one path, the absolute difference between all the adjacent elements will be 0. So I can say for this, the path's effort is 2, while for this, the path's effort is 0. Got it? So which algorithm comes to your mind whenever you hear something related to path, shortest path, minimum kind of thing? Which algorithm does come to your brain? The algorithm that comes to your brain is definitely Dijkstra's algorithm, because that is one of the algorithm which is related to shortest path, and that always involves something like a source to destination. So let's try that algorithm out and see if we can reach our answer or not. This is how you relate a problem to an algorithm, because shortest path, okay, what are the algorithms I know? Okay, Dijkstra, source and destination is there. Maybe we can try that out and see. And then you give it a dry run and see if it is working. And then you figure out, yeah, this is the algorithm which can fit in. And then while giving the dry run, you tend to understand, okay, this is the reason we are using it. always follow the standard process of mapping algorithms to a problem, that is figuring out keywords and then figuring out which one is applicable. Okay. So in Dijkstra's algorithm, what is the initial configuration? A priority queue and a distance array. So let's quickly take it up. So this is how the initial configuration looks like. We will take a priority queue where we will be storing the difference. Since we always require the minimal difference, we'll try to keep the difference at the first, so that the minimum heap or the priority queue, you can use a minimum heap, always stores the minimal at the top, and then the row and columns, which are basically the coordinates of the node. And we can assign a distance and make sure everything, yes, everything is marked as infinite. Apart, infinite is basically a very big value. Just the source, yes, with a zero, because the source is where you do not need anything. Yes, the source is the only point where you do not need anything. So what is the starting point? You always say difference is zero and the coordinates are 0 comma 0, and you put that into your priority queue. Done. Let's quickly start the Dijkstra's algorithm. Dijkstra's algorithm states, okay, I know one thing for sure. We are at 0 comma 0, and till now the difference that we have taken, and till now the difference that we have taken is 0. And we know for a path, the effort is maximum of all difference. Remember this, max of all difference in the path. So we know this, right? So what I will do is I'll keep that in mind, and I know till now the difference has been 0. So I'll try to go in all the directions, and it states we can go in the top, which is not possible. We can go here, we can go here, and we can go here. So if I go to the right, which is 2, if I go to the right, which is 2, that's nothing but the coordinate 0, 0, 1. So I'll write the coordinates as well, 0, 1, 2, 0, 1, 2. So the coordinates is 0, 1. And what will be the difference if I go here? The absolute difference will be 1. So can I say the new difference is 1? Can I say the new difference is 1? And we know max of all difference in the path is what the effort is. The effort is very simple. The effort is always recognized as max of all. So previously I took a difference of 0. Now I'm taking a difference of 1. So if I follow this path, what will be the effort? Yes, 1. So I know the effort is 1, which is lesser than infinity. So I take difference of 1 and I say this is the effort that I will take in, and I'll put in something like 0 comma 1 into the priority queue. Done. Now can I go to the down? Yes, I can go to the down, which is 1 comma 0 as the coordinate, and the difference, if you find the difference, it's 1 3, so the difference will be 2. Now previously the difference taken was 0. Now I'm taking a difference of 2, and the path effort states maximum of all differences. So 0 and 2, which is the maximum, 2. So you'll just replace 2 and as a 2 comma 1 comma 0 is what I'll put into the priority queue, and I'll just erase this because the iteration is done. Now, if you go and look at the priority queue, which one will be at the top? The topmost element will be this one because you are looking for the minimum guy. So this one will be at the top. This one will be at the top. So what I'll do is I'll just quickly take, I know the difference taken as of now is 1. I'm standing at 0 comma 1 because that is where you're standing. So once you've done this, you can omit this from the priority queue. Now from 0 comma 1, where can you go? You cannot go on the top. Can you go here? Yes, you can go here, which is 0 comma 2. You can go to the right, which is 0 comma 2. So if you go to the right, the difference will be 0. Remember this, the difference will be 0. So over here, the difference is 0. But previously, you have taken a difference of 1. So this path that you're taking still has an effort of 1. You just cannot take 0 because you're required to take the maximum. So you will be like, I'll still take 1, which is better than what we have here. So 1 comma 0 comma 2 is what I'll put it into the priority queue. Done. Now can I go down? Yes, I can go down. We have a 2 and we have a 8 on the down. So 1 comma 1. So if there's a 2 and there's a 8, what is the difference? Perfect, 6. Now previously it took till here, it took a difference of 1. I'm taking a difference of 6. What will be the new effort? Yes, 6. So I'll be like till here, I can take a 6. So 6 comma 1 is what I'll update. Once I've done, I can say the iteration is done. I'll quickly omit this off. Done. What is the next step? Get the minimum out of the priority queue. Which one will be the minimum? Definitely 1. So I'll just take it out, which says the difference is 1. and the coordinates are very easily 0 comma 2, right? That's the coordinate. So I'll just write the coordinate 0 comma 2. Now we are at here. Can we go top? No. Can we go right? No. Can I go here? Yes, which is 2. So I'll try to go here, which is 1 comma 2. Very, very important, which is 1 comma 2. So you're at 1 comma 2. And what will be the difference? The difference will be 0 because there's a 2. There's a 2. So the difference is 0. But previously I've taken a difference of 1. So you'll just update it with 1 and you'll say 1 comma 1 comma 2. Perfect. Can I go to the left? Yes. And if you go to the left, what do we have? We have 2, which will be a difference of 0, and that's 0 comma 1. 0 comma 1 with a difference of 0. Now, the difference over here is 1. This is 0. So the effort is still 1. And you have already taken 1 effort. So no need to take it. So I can say the iteration for this is also done. Okay. Now let's get the next thing. Which will be the next guy in the priority queue? Obviously 1 comma 1 comma 2. So the difference is now 1. And you are at 1 comma 2, which is this portion. Can I go top? I can go top, but if I try to go top, which will be 0 comma 2 with a difference of 0, then also the maximum is 1, which we already have over here. So we will not go to the top. Instead of that, can I go right? No, there's no one. Can I go bottom? I can go bottom, which is 2 comma 2, which is apparently your destination. Will you take this? No. You'll wait. You might find someone better. That's why you'll not conclude as of now. You will not conclude as of now. You'll be like, okay, 2 comma 2. What's the difference? 3, because 2 to 5 is difference of 3. So now, previously 1, now 3, which is the path's effort. The path's effort will be 3. I'll just update it to 3 and I'll say 3 comma 2 comma 2. Put it into the priority queue. Do not conclude your answer now. Do not, because this is not your answer. So I'll omit this. You could try going to the left as well. It'll be a 6, which is already there. So there's no point in going to the left. Next, which one will the priority queue give? Obviously, this one, 2 comma 1 comma 0. So I'll take 2 comma 1 comma 0. Now I'm saying the difference is 2 and we are at 1 comma 0, which is particularly this coordinate. Correct? Now, from here, where can I go? Can I go to the top? I can. So if I try to go to the top, which is 0 comma 0, the difference will be 2. And previously it was 2 as well. And we already have a 0. No point in going there. Can I go to the right? We can go to the right. Yes, we can go to the right. And if we go to the right, which is 1 comma 1, the difference will be 5, which is better than the previous difference, 6. I'll be like, let's take this off. Let's say 5 comma 1 comma 1 into the priority queue. Perfect. Can I go down? I can, which is 2 comma 0, and the difference will be 2. If you try to go down, the difference will be still 2. So I'll just update it to 2 and I'll say 2 comma 2 comma 0 in the priority queue. Once this is done, there is no left. I'll just omit this. Perfect. Amazing. Next, what will be your job? Your job will be to go into the priority queue and say, which is the minimal? And you see there's a 2, there's a 5, there's a 3, and there's a 6. So apparently, the 2 comma 2 comma 0 is the minimal. So I'll just take the 2 comma 2 comma 0. It's like the difference is now 2 and we are standing at 2 comma 0. Where can you go is my question. It's very easy. You can try to go to the top, which will give you a difference of 2, which is already there. So no need to go. You can try to go to the right, which is infinity. So yeah, we can go to the right. So let's try to go to the right, which is 2 comma 1. And the new difference will be 2 because that's the difference. And difference is 2. Still now it's 2. So the maximum will still be 2. So update it with 2 and say 2 comma. Yes, 2 comma 2 comma 1. Can I go bottom? No, there's no bottom. Can I go left? No. So this iteration is also done. Perfect. Let's get the next element out of the priority queue. What will be the next element? 5, 3, 2, 6. 2 obviously. Let's take it out. So I can say the difference is 2 now. And we are at 2 comma 1. We are at 2 comma 1. So if you are at 2 comma 1, where can you go? You can go to the top, which is 1 comma 1. Basically this. And the difference will be 5. And the difference will be 5. But we already have a 5 difference. So no need to take. Can I go to the right? We can. Which is 2 comma 2. Which is the destination. Which is the destination. And this time, the difference is 2. Point to notice. Because the difference is 2. And difference is 2 and it's 2. It's better than 3. It's better than 3. So you say 2. And you say 2 comma 2 comma 2. You say 2 comma 2 comma 2. Perfect. What's the next thing? Can I go down? No. Can I go left? I can, but it'll yield a difference of 2, which is already there. So I can say this is done. The next point is very, very critical. You look at the priority queue and say, who is there? There's a 2, there's a 5, there's a 3. And you get 2, comma 2 with the difference of 2, which means the path effort. You've reached your destination. You've reached your destination. In future, will you get someone better? The answer to that is no. Because if till now it is 2 and priority queue says you always get the minimal, in the future, even if someone comes up, you will be greater than 2. Like the difference might be smaller, but when you take the max, it will end up being a minimum of 2. You cannot go lesser than 2 because you had someone like, if you see, you had someone like 3, but before 3, 2 occurred. In the future, it will be either more than 2 or 2. Cannot be 2 because you are jumping to a path where already the max effort taken is 2. So even if you cover another portion of a path, whatever the effort is, even if it's like 1, 0, the difference, 2, the max has already been 2. So if you combine the max with the other guys, it'll still be a minimum of 2. Cannot be. Cannot be lesser than 2 for sure. So I am definitely sure once I reach the destination by taking out of the priority queue, the answer is for sure this difference, which is ultimately your effort, and you can just go across and return that effort as your answer. So it's a very, very simple implementation of Dijkstra because Dijkstra always keeps the track of the short, like of the path value, and you're looking for minimum path value. So you always have the minimum path value. In future, it's gonna just increase. So keep this in mind, and we're gonna implement this now. So I hope you've understood the entire approach. Now it's time to code it up. So I'll be coding the C++ on the right, and you can find out the similar Java solution on the left. So we're given just the heights. So you can use the set data structure as well, the Python as well, whichever, the priority queue as well. So I'll be using the priority queue. So this time we have to kind of take a bit more pairs. Like we need another thing. So let's just quickly upgrade it to, yeah, that's the thing. And over here, if you just a minute. Perfect. I have declared the priority queue. And this is how the priority queue looks. It's a very long one, but yeah, that's how it looks. Like if you just break the line, you can probably read it. So this is how the entire priority queue will be defined. So I'll be keeping something like, if I show you the structure, this is how I'll be keeping the structure as. I'll keep the difference and I'll keep the row column. Pretty straightforward. That's what the structure is going to be for me. You can probably create a class as well, but then you have to write the comparators, which I don't want to. What's the next thing? You require the size of the heights, so probably you can just take compute the size, and you can just do heights 0.size. You'll get the m as well. Now what do you require? You require something like to store the difference. So maybe you can create the distance array or the difference. We can call it as the difference or the distance, just to be familiarized with the name. So you can go across and declare that as well, vector of int, and make sure everything is marked as infinite. Done. That's the first thing you'll do. What's the next thing? Make sure you iterate on the priority queue till it is not empty. But before that, do you need to do anything else? Yes, you do need to do something like distance of 0, 0 will be 0 because you know that's the starting point for you. And what is the other thing that you have to do? You have to also say the priority queue to store the first guy, which is 0, comma 0, comma 0. Perfect. That's the easiest thing. Next, let's go across and take the pq.top. So I'll just take the pq.top and I'll just say pq.pop. And once I've done this, I can take the new diff rents, which is nothing but very simple. Like if you say it.first, you'll get it. And if you need the row, again, it's quite eminent. It's something like it.second.first. If you need the column, it's going to be it.second.second. Now, there are 4 directions. One is the top quotes, which is the row -1, comma column. Then the other one is the right one, which is this. And there is one at the bottom, which is row -1, comma column. Then there is one on the left, which is row, comma column -1, right? So what I can do is, I can probably create, I've already taught you this in a lot of videos till now. So -1, 0, 1 and 0, and then I can have something like DC equal to 0 comma 1 comma 0 comma minus 1. I can definitely declare it something like this. And now what I'll do is I'll just go across and say I equal to 0, I lesser than 4, I plus plus, and I can easily traverse to all the adjacent nodes. It's very simple. You can say new R will be current row plus nothing but the change in this, and you can say new column equal to column plus DC of I. So what will happen is first time minus 1 and 0 will get added because this is over here. Next time 0 and 1 will get added. Next time 1 and 0 will get added. Next time 0 and 1 will get added, and you'll get it. First thing that you need to do always is to check if they are valid or not. So please go ahead and check if they are valid or not. So very simple check. You can probably put them into different functions if you wish to improve code readability. And what after that? Now, you know one thing, you have checked for validity, right? What is the next thing you need to check? You need to check if the difference that you are getting is it lesser than the thing stored in the previous one, right? So probably we can first check for validity, because after that we can find out. So what is the new effort? Can I say the new effort will be nothing but max of the current effort, which is nothing but absolute of wherever you are. Yes, wherever you are, which is heights of row column. So let's write heights of row column. This is currently where you are, right? And can I say heights of new row and new column is where you're trying to go. So this is what the new effort that I'll take, and I'll just take it with this. So if new effort, like the max of this, so once you've got the new effort, what's your job? You have to see if the new effort is lesser than whatever you have taken till now, which is distance of new R. If previously you would have reached, otherwise it would be infinity. If it is, then you go across and say, hey, listen, distance, you got someone better. Please go ahead and just do it. Right after that, you'll say PQ dot push this distance, which is distance of, or you can write new effort, simple. This is the new distance. And you will at the same time say new row, because that's the new coordinates, and the new column. Once you've done this, you can, I can say we will reach here. But where did we get our answer? If you remember the approach, we said whenever we get our answer over here, which is this and this, because not while here, because we might find minimals afterwards. You saw in the example. I'm going to return over here the difference. Whatever difference I'm getting out from the priority queue, I am going to return. Remember this, I'll go and compile this and see if it is working fine. It is, and I'll quickly submit this to see if it is giving us correct answers. So it does give us correct answers. Now it's time to discuss the time complexity. You know that Dijkstra's time complexity. It is always E log V. If you want the derivation, previous video. In the previous video in the same series, I have derived time complexity. It's E log V. What is E? The total number of edges. So how many total number of edges we will have? If it's a grid, you know, in grid, there will be n cross m cells for sure. There will be n cross m cells for sure. And for every cell, there is 4 directions. So that is the total number of edges. Because for every cell, there is n cross 4 m. Cross log V. What is V? The total number of nodes. How many nodes are there? Number of total cells, which is n cross m. Got it? So this will be the time complexity of this particular algorithm. And you're using n cross m space, and the priority queue uses a bit of space. So you can say the approximate space is near about n cross m. And this is how it will be done. So guys, I hope I was able to explain you the entire solution and the code. So just in case I was, please make sure you like this video. And if you're new to our channel, what are you waiting for? Hit that subscribe button right away. And if you haven't checked out our DP series and the HD sheet, the links are in the description. With this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.
Whenever your heart is broken.